Hello everyone, and welcome to my group's video presentation. In this video, my group members and I will be talking about Geiger Muller. But first off, let us introduce ourselves.
My name is Muhammad Nur Hisham bin Afizar. My matrix number is 058300.
Hello, my name is Muhammad Shirvazli bin Abdullah and my matrix number is 058226.
Hi, my name is Mugad Alif Hakimi bin Megazlan and my matrix number is 058305.
My name is Ahmad Farhan bin Zaini. My matrix number is 058266. Now, in case you're all wondering what a Geiger Muller looks like in real life, we actually have some images in our slides here that shows what it actually looks like in real life. It's actually a box that is colored in yellow and black. It has a handle on top of it, and it has this black cylinder called the Geiger tube, and it's attached to the box with a spring.
Introduction of the GM tube. So the Geiger Muller tube, often known as the GM tube, is the sensing element of a Geiger counter used to detect ionizing radiation. It is named after Hans Geiger, who invented the idea in 1998, and Geiger Muller, who worked with Geiger in 1928. So they collab and produced the GM tube to improve the process and create a functional tube that could detect a variety of radiation types. It's a gaseous ionization detector that uses the Townsend avalanche phenomena to generate an easily detectable electrical pulse from a single ionizing event caused by a radiation particle.
Now on to the functions of Geiger Muller. It is a handheld device used for detection and measurement of ionizing radiation, such as alpha, beta, and gamma. The end of Geiger tube is faced towards the source of radiation to detect the radiation and measure its intensity. Scale meter shows the radiation intensity in unit of counts per second. Abbreviation for counts per second is CPS. It is used widely in radiation applications such as dosimetry, radiological protection, experimental physics, and last but not least, nuclear industry.
Operation principle of Geiger Muller tube. Geiger Muller tube was pumped with gas argon at a low pressure. Ionizing occurs when a beta or gamma ray passes through ionizing chambers. Then, the electrons form argon atoms, resulting in an avalanche. The charged ions will further collide and produce more ions. In this phenomenon, small numbers of ions is greatly counted, resulting in easily measurable impulse that can be amplified. Precautions when using Geiger Muller tube. First, do not touch the window because it is very fragile. Always apply low voltage in platter region to avoid tube damage. Second, the tube is to be operated in the housing supply in order to protect the window. And lastly, operating voltage of the Geiger Muller should be determined before conducting any measurement.
The advantages and the disadvantages of the GM tube or Geiger Muller tube. So firstly, let's go to the advantages. The advantages of the GM tube. Firstly, it has a high amplification. Maximum amplification factor can reach up to 10 power of 10. The primary ionization and detected proton energy can produce strong signal, which avalanche with shape and height independently. And next, the voltage pulse may be large and detectable, nearly 1.6 volt. The construction simplicity and small insensitivity towards small voltage fluctuation, and the subsequent electronic amplification is not required also. So next one is the simplicity of the GM tube. Firstly, the GM tube is portable instrumentation which we can carry anywhere. Plus, it has a mobilization benefits. It also more sensitive to low energy and low intensity radiation than proportional ion detectors. The last one is the compatibility with simpler electronics. So firstly, it can be used with simpler electronics packages. For example, sensitivity of a typical GM survey instrument is 300 to 800 millivolt, while the input sensitivity of a typical proportional survey instrument is 2 millivolt only. So the disadvantages is the discrimination is impossible due to the independent type and the energy radiation pulse height, which are subject to no particle identification and energy resolution. Next one is the cost by the size of avalanche is independent of the primary ionization which created it. So the last point is the dead time. It takes a long time to recover, nearly plus minus 1 millisecond between successive pulse due to large avalanche induced by any ionization, unable to measure high radiation rate due to the dead time, or as we call it, the recovery time.
Now, take a look to importance of radiation measurement. First, radiation measurement can identify sources of radiation and take further steps to reduce unnecessary radiation exposure with a goal to minimize the harmful effects of ionizing radiation to workers, medical staff, and public. Second, to keep radiation exposure as low as possible in accordance to ALARA, as low as reasonably achievable principle. And lastly, prevent radiation dose from exceeding the recommended dose per year, as you can see with the pictures provided.
And with that being said, I believe we've reached the end of our video presentation. These last two slides are just references that we've used in our video. And that's all from us. I bid Sadaqallahul Azim. Thank you for watching and have a nice day, everyone.